G'day guys, in this video we'll be having a look at this little nifty thing I built over here. This is a capacitor tester, high voltage capacitor tester. It goes up to about 375 volts DC. Here's the schematic. It just uses a normal isolation transformer, then it goes into a full bridge rectifier, filtered, then through a MOSFET, and then into the current shunts and meter. So it's a pretty straightforward schematic. In fact, I can open it for you here. So here's the unit open. Get a close up of this. Here's the transformer. It's just one straight from China. If I can get a good angle to show what the outputs are. So it's two 115 volt primaries, and then I just put them in series because we have 230 volts. And there's two orange wires, 240 volt at 50 milliamps, if you can read that. And these other wires, I didn't need them. They're just either 9 volt or 6.3. I left a little bit of extra lead on that just in case I ever use it for something. If I ever wanted to, I could go onto a different tap here and use it on 115 volt. So if you have a look at the inside here, I'll try and get a good lighting. It's pretty crammed in here. You have the MOSFET just up in here, and filter cap, just resistors. There's your full bridge rectifier, and there's the 3 shunts. Voltmeter, there's the output, there's the shunt selector switch, and there's the 100 microamp meter, and down the corner there's the potentiometer for the variable voltage. So it's there's not a lot to it, but I can't exactly fit much more in this case. It's pretty crammed, and this transformer adds a bit of weight to it too, adds a bit more oomph, I guess. So yeah, I can put it back together and we'll try it out. But also, if you're wondering, I did not design the schematic for this. I got it from, I forgot his name, I think he's from Germany. I'll leave a link to his video in the description, but I based my capacitor reformer off his. So thank you for designing that. Forgotten your name right now, it will be here. I can show you the operation of this, so I can turn on at the PowerPoint. This is the voltage potentiometer, and I'll zoom in on that. And as you can see, there's a minimum voltage. I think it's just above 30 volts, so you can swing it right up and down. This voltmeter, there's something not quite right with it. It's not 0 to 400 like advertised. It's more like 0 to 480. So that's why I relabeled it. This microamp meter, that on the other hand is quite accurate. So you have the different settings. So right now it's just off discharge position, where it has a 2 watt, I've forgotten what the resistance is, resistor right across that. Then you can apply it 100 milliamp, 10 milliamp, 1 milliamp, and then 100 microamp. So we'll turn the voltage off there, bring the voltage right down, and I have quite a few old capacitors that I've collected over time that I can test here. This one that I had sitting around, this is a dual 40 microfarad 150 working volt electrolytic. So we can test how much leakage it has. Can hook up the first section, the green section, just there. Then it's on minimum setting, so we can just apply power. What I like to do is have my multimeter right here, and bring the voltage up using the multimeter so I know just how accurate it is. So we can bring it up. You can see this meter rising a little bit. Let's bring it up to 140 volts. There you go. So it's a 150 volt rated cap, so we can flick through the ranges. See, we have about 150 microamps of leakage. Now this will go down. I haven't labelled this yet, so I always tend to forget exactly how much leakage it is, but this will drop. This actually reads okay. I've actually tried reforming this capacitor before, so now we're down to the 100 microamp scale. I'll let it drop for a little bit. You can see there's 100 microamps of leakage. It waves a bit around. It's interesting on such a tiny scale, you know, 100 microamps being 0.1 of a milliamp, you know, it's very sensitive scale. Is that the reason why it waves around so much is not only because the capacitor is reforming, which it does tend to wobble a little bit because of that, but it's mainly because of the fluctuations in the line voltage. Which is the only downside to the circuit, is it's not regulated before it goes into the MOSFET, and because of that, you see this. So it, you know, if someone's toaster turns on, it will dive down because it's pulling the line voltage down. If the air conditioner turns off, it'll swing right back up. That's just what you expect from such a tiny scale. So when I leave it to reform a capacitor for a little while, I wouldn't leave it on the 100 microamp scale. I would put it on the 1 milliamp scale, just because it's not could peg the meter. But you can see we're already down to about 70 odd microamps. A little bit more, a little bit less. Seems to be travelling a little bit. So that's pretty good. That's about what I would expect for a good capacitor of this age, being that it has been around for, you know, it's probably from the 1960s or something like that, so it's probably got PVC oil, you know, good stuff. In fact, it actually came out of this little piece of kit here, this RCA signal generator. And I've got a few more capacitors we can try out here, and this is not all the capacitors I have. I have other ones. There's a selenium rectifier I'm working on, power supply. Well, I guess we can test this old Elna. This is a new old stock Elna from probably the early 1980s. It's rated for 315 volt DC and 100 and microfarad section and two 150 microfarad sections. So it's a 3-section electrolytic, and we can test that too. It's pretty old, new old stock. You'd be surprised. Some of these capacitors test really bad, while others they actually kind of recover after so much time. Like this one here, this is still falling. This is around, it's around 50 microamps now, and it will continue to fall after time. I would say it would self-heal being in circuit now. What you definitely don't want to do, this is current limited, not just because the transformer can only put out 50 milliamps, but also it's got a 12k 2-watt resistor. So if worst comes to worst, you can't even get put out 10 milliamps. See, that's exactly why. Saw that peg backwards. That's why you don't leave it on the 100 microamp scale. But it can't self-destruct capacitors. It won't allow for that. That's something you just want to be careful of with old capacitors. You want to slowly bring them up. You don't want to just hit them with 300 volts and just hit them. They'll get really hot, especially these can capacitors. These things can explode. If you give them an inch, they'll take it, and it'll be the worst day of your life. But this capacitor is going pretty good. It's a okay capacitor. You can see fluctuating around a fair bit, but that's alright. I've got some others here, so we can try out some other ones. We can try out this little tiny 8 microfarad 160 volt Ducon, which is dated 6th week of 1971. So that's been around for a while, but we can test it here. We can turn the voltage off completely, cut the voltage to this capacitor, 40 microfarads, so it's in the discharge position, so we should be reading just about nothing. Yep, it's already down to 2 volts. Well and truly safe. For normal electrolytics you would find in a old valve radio, you know, that aren't ridiculously high capacitance, it will discharge them pretty quick. So you can practically grab them straight away and not be worried about it. So let's test this Ducon here. So this is 160 volt, so we can try that. What voltage is it? 145, so it's been creeping up. We can bring this up a little bit more. Not that high. We'll let it sit around 155 volts. And we'll turn down the scale here. Yeah, nothing, and that's the 100 microamp scale. Look at that. About 10 microamps of leakage. If you can believe that. Capacitor that's about 30, geez, how old is that? Well, like 48 years old. That's really good. Only about 10 microamps of leakage. I would be perfectly fine with this capacitor being in circuit. This is an old Ducon electrolytic, made in Australia, of course. Ducon was bought out by Plessey, so it's now a UK company, which I think they make capacitors for like fluoro lights and air conditioners and stuff like that now. You don't really see them. I don't think I've ever seen them, but these are the old Ducons. But look at that. 10 microamps of leakage. That's really good. So let's check something that I know will be bad. So you don't have to just check electrolytics with this. You can also check wax capacitors and that. You can, because it's such a tiny scale, 100 microamps, you can read right down. So let's check a wax capacitor in particular. If I can grab one here, a Bumblebee Capacitor. If you've never seen a Bumblebee Capacitor, don't worry. They're just an old oil-filled paper capacitor that was popular in the 1950s and 60s. So this is a orange, oh sorry, red orange, which is a 22. So it's 22,000 picofarad, which is what? So it's a 0.022. At yellow is, I think yellow is 400 volts. Yes. So it's a 0.022 at 400 volts. These don't have a polarity. So I'll hook that up and see how much leakage one of these old Bumblebees have. So let's go straight down to the microamp scale and zoom in here, bring it up, and we already have leakage at about 80 volts. So let's just bring it up all the way, and there we go, over 50 microamps of leakage. These should read 0. A good paper capacitor will read 0. You'll never get 0 leakage with an electrolytic. That's just a characteristic they have. But paper capacitors, they should read 0. That's why they're not made anymore, because when paper is exposed to air, it becomes acidic and leaks DC, which they shouldn't. It won't really fluctuate that much, because, you know, they just they don't improve. Once they're bad, they're bad. So let's try another one. Put that back in the bag of old capacitors. Alright, so let's check one of these old Nippon Chemicons. This is a oil-filled capacitor, Nippon Chemicon, 0.1 microfarad at 400 volts. I've discovered that these things have a very interesting characteristic, which I will demonstrate in a moment, where they want to, well, I won't spoil it for you, hook that up there, whack it, bring it up a bit. Ooh, geez, 600 microamps of leakage already. That's horrific. 600 microamps of leakage. Yep, I can bring it up. This is the, yeah, and look at that. So that's the characteristic I was talking about. It's actually rising in leakage. If this thing was left in circuit, where it wasn't current limited, this thing left for a couple of minutes, this thing would just explode. Look at that. So that, what's that, 6 milliamps? 7 milliamps? Yeah. Yep. 7 milliamps. Nearing on 8. That thing's getting warm. If I touch that, that's getting warm to the touch. Ooh, yep. 9 milliamps. Yep. They're bad. That's horrifically bad. It's worse than, it's the worst paper capacitor I've ever seen. Should be, I actually should blow these up one day just for the hell of it. For fun. Should video that. Whew, yeah, that's warm. That's warm to the touch. Got some others in here, so let's try a Matsushita 1 microfarad, 250 working volts. Let's try you. Let's go, just whack that on, power it up, 100 microamp scale, no leakage. Let's go out to 240 volts here. Look at that, it's actually good. After all that time, it's got practically nothing. It's actually twiddling a little bit, So I have no idea how long it would last. I would never put a paper type capacitor back in circuit, but yeah, that's that. So they're not as nearly as bad as the old Nippon Chemicons, but I wouldn't trust this in everyday circuit. Right, what else should we try? I have some of these so-called mustard capacitors. These are two 1 microfarad 160 working volt capacitors. So there you go, look how funky they look. So I'll just test one of these, hook that up over there, and we'll hit it. Just bring it up slowly. So that's 120 volts and no leakage. Look at that, still good. I'm not sure what mustard capacitors are made of. They might be Mylar. Not sure about that. You can look that up in your own time. But yeah, that seems to be still good. So bring it back down again. They apparently aren't bad. What should we check now? Oh, these things are pretty interesting here. These are. This is actually a Ducon. If I bring it into frame here, forgotten what these are called. Actually, there's sometimes you rarely find these in valve radios, but I have found a couple, like this one in particular. There's a 0.01, 200 volt. It's pretty small. This isn't paper, but these things still leak. I don't know how, but they still leak. So 200 volt rated, that's in. Hit it, bring it up. Well, that one doesn't leak. I think it was this one or something. It was leaky, but so we could try. I have a massive Bumblebee. What is this? This is a it's a 0.27 microfarad at 200 volt. 0.27, bit of an odd value. That would never be made anymore, probably, chances are. And we already have leakage at the minimum voltage. Let's bring this up. 200 volts, 40 microamps. So it's actually dropping. Yep, interesting. Bring it up here to about 160, about 70 microamps. So definitely a leaky old Bumblebee capacitor. That. So any wax capacitor or just any capacitor you're not sure about, it's just swap them. I mainly built this capacitor tester for modern capacitors to reform them before I put them in circuit, just because it's nice to know that your electrolytics are properly reformed after sitting for how many years on the shelf, So this is a 600 volt 8 microfarad Ducon. This is from the 1950s. It's from 10th week of 1954. There you go. It looks pretty crusty if I zoom in on that. There you go, that's pretty crustastic. We'll turn the voltage down, hit it, and we have leakage This is on the 100 microamp scale. We have about 20 microamps of leakage at 120 volts. And you can actually see it dropping down there. There you go, 500 microamps. So that's actually reforming. That's actually surprising that that might actually recover after a long time. Like, it's been chewed on by like a mouse or something at some point. It's honestly surprising that it's reforming itself. We can go to the milliamp scale and we'll just bring it right up. Ooh, that is not good. That is a sign it's shorting. Ooh, yeah. Ooh, yeah. See that? That was shorting out then. Ooh, yeah. See if we can get it to do it again. Doesn't look like it. Looks like it temporarily shorted and it just blew it out. Surprisingly. Yeah. So whenever a capacitor temporarily shorts like that, and even if it blows it out and starts working again, don't trust it. It's not worth the risk at all. In fact, generally with these capacitors I'll just replace all of them. But in my own test gear, well, not in test gear, but just some cheap old radio, if the electrolytic's okay, I might just leave it in there. It's not really worth buying a new one in instances like that, but things like this, yep, I would just instantly replace that, just because of how dried out, cracked it is, and the fact it actually showed itself shorting. But it is actually coming down in DC leakage. It's below 40 microamps now at the highest voltage range. Obviously we can't test it at its peak voltage, but yeah, that's as high as we can put. That's as much as we can put into it with this unit right here, which is tested out 376 volts DC. And yeah, you could actually see how much current the multimeter is pulling on its own. But anyway, can bring that back down, and we can test another one. It's this is a nifty little one. This is a Ducon. This is with an oddball. This is a 1 microfarad, 300 volt. Still got massive leads on it, so make sure not to short that out. But hit it with power. We'll bring it up. Set it on 240 for now. Oh yeah, it's the only downside with having a resistor in there is, as the resistance, well, current drops, the voltage rises on its own, because the voltage drop across the resistor decreases. So that's the 10 milliamp scale, so that's 400, or just over 300 microamps of leakage. And it's right on 300, and that's slowly but surely dropping down. If I left it on there for a few minutes, it would probably drop right down and become a healthy capacitor again, but a 1 microfarad capacitor isn't really all that useful. Surprised they even made it on a 1 microfarad electrolytic at 300 volts. I don't know why they didn't just use some sort of wax capacitor, but I mean, it would have been pretty big. Now you would have just used a Mylar capacitor, because they're not that big. I mean, they're still bigger than that, but you know, they're not that big. not much bigger. It's not really worthwhile. Let's see if we got another interesting one. Yeah, okay, we have this 350 volt, 8 microfarad. Zoom in here. TCC micro pack electrolytic, made in England. So we can see that, yeah. See, it's already dropped down to just above 100 microamps. So it would probably fully recover. So we can take that out. Put in this 8 microfarad. Okay. Hit it with power. You can see the meter drop. And slowly rise it up. And it's slowly dropping. So it's dropping pretty fast. We'd probably even wait for this. You can see that. It's dropping at a pretty reasonable speed actually. Might actually reform pretty quickly. What voltage are we putting into it? 250. I guess we could crank a little more into it. It's rated for 350 after all. Let's put 320 into it. That will rise on its own as well. So what's that? 110. So that's just under a microamp. Yeah. Dropping. $700 microamps. Yeah. And as it does this, of course, the voltage will rise back up. So if we check it right here, see that that's already at 329, and it will slowly rise, or not, whatever. That went from 320 to 329, so 328, yeah. So that's alright. 400 microamps. That's well, it's slowly recovering, rebuilding itself, and you know, it might be alright over a little bit of time, but yeah, for the most part I would just replace these electrolytics, but you know, sometimes you can, in a set you don't really care about or not worried about too much, that's not running all the time, which, you know, most valve radios aren't running all the time these days anyway. You can generally just leave the electrolytics in there if they test good. And this is a very good example why these things are handy, because it's something you can't test with a multimeter that checks capacitance. You may be able to read the capacitance, but you can't measure the ESR and leakage. You can't measure the ESR with this either, but you can measure the leakage, which is very important, so you can actually test this at higher voltages, and you can be sure that your electrolytic will be okay running in circuit. Well, I guess for the last capacitor we can try this one out. So that's at 400 microamps now. That'll probably fully recover over time. It's not even warm, so I would expect it shouldn't be warm. So let's just check one of these sections. Check the yellow section, which is a 150 microfarad section, and zoom in. This will chuck a bit of power. First turning it on, and we can get 10 microamps. See that? See how much that's rising? Right there. It's coming down. don't want to cram too much into it. It's only it's rated for 315. 256, 258, yeah. $280 there, and well, it's a milliamp of leakage. It's dropping. As you can see, it's slowly dropping, so it's just above 500 microamps now. See how much current it's pulling. There you go, it's below 289. And yeah, it's reforming as well. But this would have to be on there for a fair while before it would be fully reformed. So there you go, it's under 400 now. It does take a couple of minutes for electrolytics to settle down, even new ones. Not as long, but they take a couple of minutes just to fully form when you first power them up for the first time in a while. So yeah. So it's down to, where's back up again? 300 microamps. Yeah. So there you go. Don't forget to like, share, subscribe. See you in the next video. I have no idea what I'll be doing it on, but hope this was interesting for anyone who wanted to know about older electrolytics and capacitors in general. And thanks to the guy who designed the schematic, because it was much easier just to go off what someone else had made and tested to be working rather than making my own. And this is a handy little box for high voltage big capacitors. Like I'll just demonstrate here. Like this big whomper. This is one I pulled out of an old UPS, 3300 microfarad at 450 volt. So I left 2.2 meg across that just to stop it from rebuilding and charging it, so it doesn't shock the shit out of me. And yeah, very handy for modern capacitors as well, not just vintage ones. So guys,